Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from November 2023. This paper is worth 120 marks in total, and this is the fourth video of 6. It will focus on questions 16 to 20, which account for 19 of these marks. Eduqas Component 1 papers are non-calculator papers, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 16. Gary owns a garage selling second-hand cars. On Saturday he had 72 petrol cars and 48 diesel cars for sale. Part A. Write the number of petrol cars to the number of diesel cars as a ratio in its simplest form. Okay, so we're writing them in that order, guys. Petrol to diesel. Well, petrol is 72, diesel is 48. So I've got my starting ratio. That's going to get me a mark. Now I need to get it in its simplest form. Now I don't have a lot of space here, so what I am going to do is try and find my highest common factor of 72 and 48 to save myself a little bit of time. So factors of 72. We will have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5 dozen, 6 and 12. Okay, and then for 48, I'm going to do that here, guys. 1 and 48, 2 and 24, 3 and 16. But I'm going to stop there because I think my highest common factor is going to be 24 because they're just going to go down here. So I'm going to divide both of them by 24. So 72 is 24 times 3. 48 is 24 times 2. 3 and 2, the highest common factor is 1. So that is my ratio in its simplest form. Part B. What percentage of the cars are diesel? Okay. So let's see how many, actually let's work with our ratio. So we've got 3 to 2 in our ratio, which is petrol to diesel, okay? We're interested in what percentage of diesel cars there are. Well, 3 plus 2 is 5. So this ratio has a total of 5, but when I'm working with percentages, I want to work with a total of 100, okay? There are 25s in 100, so I would have scaled up by multiplying by 20. So I'm going to do the same to my ratio. 3 times 20 is 60. 2 times 20 is 40. I want the percentage of cars that are diesel. So this is 40 out of 100. Percentages are out of 100. So it's 40% of those cars are diesel. Question 17a. Calculate 12% of 750. Okay, so I'm going to build this up using different percentages. So I'm going to make 12% by finding 10%, 1% and 1% because 10 plus 1 plus 1 is my 12%. So 10% I divide by 10. So 750 divided by 10 equals 75. 1% I divide by 100. So 750 divided by 100 is 7.5. Notice how I'm making my life easier and I'm lining up my place value columns because I know I'm going to have to add these answers together to make 12% in total. And then again, 1% would be 750 divided by 100, which is 7.5. So I'm going to add these together. So 5 plus 5 is 10. So put the 0, carry the 1, decimal point in the correct place. 7 plus 7, 14. Plus 5, 19, plus 1 is 20. 2 plus 7 is 9. So 12% of 750 is 90. Now that makes sense to me because 12% is quite a low percentage when we're dealing with out of 100. So I would want a smaller number than 750. Part B. When a fraction is added to 2/5, so a fraction is added to 2/5, the answer is 7/15. Find the fraction that is added. So something plus 2/5 is 7/15. We're trying to find that something. Okay, guys, so we're going to do inverse operations. So the inverse of adding 2/5 would be to subtract 2/5. So we're going to do 7 over 15 subtract 2/5. Now when we're adding or subtracting fractions, we need a common denominator. Now this denominator is 15, this one is 5. 5 is a factor of 15, so I'm just going to scale up one of these fractions. So 7 over 15 is going to stay as it is, but 2/5 is going to get multiplied by 3 because 5 times 3 is 15, which gives me a common denominator of 15, but I have to do the same to the numerator to get an equivalent fraction so that we're balanced. So 2 times 3 is 6. So now I have a common denominator. Okay, so I can write this as a fraction. 7 subtract 6 for the numerators all over 15. Well, 7 subtract 6 is 1. So my answer is 1/15. So 1/15 plus 2/5 is equal to 7/15. Sarah has a water container in the shape of a cuboid. So we're working with a 3D shape. The area of the base of the container is 150 centimetres squared. So this is our cuboid. This is our container. The area of the base here is 150 centimetres squared. Water is leaking from the container at a constant rate. So that constant rate is important. That's going to help us with our calculations. At 10 o'clock, the water is 20 centimetres high. At 10:15, the water is 7 centimetres high. How much water is in the container at 11? Give your answer in litres. Okay, so it's leaking at a constant rate. So to find out how much water is in the container at 11, we need to be able to find the volume of the container with the water at 11 o'clock. So we're going to do the area of the base, which we have, multiplied by the height of the water. So let's look at this information here to start off with. Okay, so we're going to look. So at 10 o'clock, it's 20 centimetres. At 10:15, it's 7 centimetres. So in 15 minutes, it's gone down by 3 centimetres. So at 10:30, in another 15 minutes, it should go down by another 3 centimetres because we're working at a constant rate. So that would be 14 centimetres. And then at 10:45, let's go down by another 3 centimetres. So that would be 11 centimetres. We want to know how high the water is at 11 o'clock. So that's the next 15-minute interval even. So we're going to subtract 3 centimetres. So it's 8 centimetres. So the height of the water at 11 o'clock is 8 centimetres. So we need to find the volume of water that's included in there so that we can then say how many litres. I know what I'm talking about. So to find the volume of a prism, so a cuboid, a 3D shape, we do the area of the base, which is the cross section that runs through the shape. So 150. So this is us working with volume here, guys. Multiplied by the height. Well, the height at 11 o'clock is 8. So we're doing 150 multiplied by 8. So I'm going to do that calculation here. 8 times 0, 8 times 5, 8 times 1. So it's 1,200 centimetres cubed at 11 a.m. But we want to know how many litres of water there are in the container at 11 a.m. So we need to convert our centimetres cubed into litres. Okay, well, 1 centimetre cubed is 1 millilitre. There are 1,000 millilitres in 1 litre. So we need to divide this by 1,000. So 1,200 divided by 1,000 is 1.2. So there are 1.2 litres of water in the container at 11 o'clock. Question 19. 120 people each completed a puzzle. The times taken to complete the puzzle are shown in the diagram below. The diagram uses groups of width 5 minutes, so from 0 to 5, 5 to 10, 10 to 15, 15 to 20, 25 to 25, etc. So we've got the frequency, so the number of people, and then the time it took them to complete the puzzle. A person is chosen at random, so we're choosing a person out of the 120. So out of 120. Okay. What is the probability that this person took less than 15 minutes to complete the puzzle. Okay, so we're working out of 120 people in total. So we need to figure out how many took less than 15 minutes to complete the puzzle. So we're interested in these people, and these people, because that is less than 15 minutes. Okay, so let's read across here. So this is 40 people, this is 30 people, and this is 20 people. So 40 plus 30 plus 20, that's 70, that's 90. So 90 out of 120 people took less than 15 minutes to complete the puzzle. With probability, we don't have to simplify that fraction, so I'm just going to leave it like that. Question 20. The diagram below shows 3 straight lines, AB, CD and GH. Show that AB and CD are parallel. So we're trying to show that AB and CD are parallel. You must give reasons to justify your answer. So not only are we showing it with working out, we've got to give reasons as well, guys. Okay, so it tells us that these things are straight lines, so that's helpful for angle facts. Diagram not drawn to scale, so we're showing that these 2 lines are parallel. They don't look parallel because they look like they could potentially meet, however, not drawn to scale. So what we're going to do is we're going to find as many angles as possible as we can to then form some kind of relationship between AB and CD using angles in parallel lines. So we're looking at corresponding angles, co-interior angles, those kind of things, alternate angles. Right, let's start filling in some information then, shall we? So I'm going to say angle AEF. So angle AEF is 80 degrees because vertically opposite angles are equal. Remember, we've got to give our reasons. So vertically opposite angles is the angle fact that I use to recognise that that angle is 80. So I'm going to say AEF equals 80 because vertically opposite angles are equal. Okay. Now I'm going to see if that helps me. Well, it does actually. And this is only a 2-mark question, so we're not expecting lines of working out here, guys. Potentially 2 steps. And I think I can do this in 2 steps. So now I've got these co-interior angles. So if I think about this here, so AB and CD, if they're parallel, then these co-interior angles, the angles that are on the interior of the parallel lines when they're cut by this transversal, so co-interior angles must sum to 180. So I'm going to write that to start off with. Co-interior angles sum to 180 degrees. But I'm going to make it very clear that these 2 angles are the ones that I'm looking at. So angle AEF equals 80. Angle CFE equals 100. So when I add those together, 80 plus 100 equals 180. Therefore, co-interior. So AB and CD are parallel. Always finish it off with a final statement, guys.